All right. So let's start. So we were looking at in traditional ciphers, we were looking at substitution ciphers, and specifically we were focusing on monoalphabetic ciphers. So the first cipher that we want to look at, which is actually a substitution cipher, where each letter is being replaced by some other letter, but we're going to look at something called polyalphabetic cipher. And in this scenario, it's actually an autokey cipher. Autokey cipher means for every single letter, you will have a different key. All right, so every single letter will have a different key, which means that's why the name autokey cipher. And here's the definition. It's still in an additive nature, that our ciphertext is going to be your plain text message, the character letter plus the key itself, mod 26. Decryption is going to be your ciphertext minus the key, mod 26. But here's the twist. Your key, so you're going to share a key, sender and receiver. There is a shared key between them, and let's say that key, let's call that key 1. Let's call that this key is going to be 12. All right, but the next key for the next letter is going to be the plain text value. All right, so let's look at a message, and let's so the next key and the following key are going to be the plain text. So let's look at it. Let's say our plain text, so is actually, we're going to do it like this. So this is our message. So attack is to, sorry, day. All right, so this is our message. So the first thing I'm going to do, I'm going to write down the values of it. So the value, according to our code book, these are the values that I'm going to use. So I hope you can see this clearly. Whereas A is 0 and Z is 25. So I'm just simply assigning some type of a weight to it with respect to some numbers. All right, so A has a value of what? 0. All right, T has a value of, so here's my T. So T has a value of 19. I hope you guys can see this clearly. 19. Another T is 19. So 0. C is 2. K is 10. We have I is 8. S is 18. T is 19. We have O is 14. And we have D is 3, A is 0, and Y is 24. All right, so this is, I'm just simply assigning the weight to it. Now here we're going to generate our key. What is our first initial key? The first initial key is actually 12, so we're going to write down this 12 value. Now the key for the next letter, which is going to be T, is going to be the plain text value, which was the previous value, P1. P1 was what? 0. So this will come down over here. The key for this one is going to be P2, 19, like this. P3, P4, P5, P6, P7, P8, P9, oh, I'm sorry, P9, P10, P11, and P12. This is how the key value is going to be. Our first initial key, which is being shared between my transmitter and the receiver, is actually 12, but the following keys for every single letter is going to be the plain text value of a previous letter. So this was P1, so this will become the key for the next letter, and so on. All right, so we can compute the cipher value now. And cipher value is just simple. How am I going to compute the cipher value? Okay, 12 plus 0. So this is my plain text, and this is my key. 0 plus 12 is what? 12. And 12 mod 26. When the modulus is bigger and the number is smaller, you will get the same value. So you get 12. 0 plus 19. All right, 0 plus 19, sorry, 19 plus 0, I'm sorry, 19 plus 0, because I have a plain text. 19 plus 0 is 19, so this would become 19. All right, 19 plus 19 is 38. Now 38, I'm gonna remove this. So 38 mod 26 is 6. So this is half of it, which means this is going to be double. So this would become 12. 0 plus 19 mod 26 would give me this 19. 2 minus 0 is 2. Mod 26 is 2. 12 is 10 plus 2 is 12. Mod 26 would give me 12. 8 plus 10 is 18. That would give me 18. 18 plus 8 is actually 26. What is 26 mod 26? Would give me 0. All right. So 19 plus 18. So 19 plus 18 divided by 26. Shift SD. That would give me 11. 19 plus 12. So 19 plus 14. That would give me shift 7. 17. 3 plus 14 is 17. Mod 26 would give me 17. 0 plus 3 mod 26 is going to be 3. 24 plus 0 mod 26 would give me 24. All right. So far so good. So this is going to be my ciphertext. So let's define this value. So what that ciphertext would be. So this 12, according to our table, will map to M. Now this 19 is T, 12 is M, 19 is T, 2 is C, 12 is M, 18 is S, 0 is A, 11 is L, 7 is H, 17 is R, 3 is D, 24 is Y. Now this is my ciphertext. Now this is why this is polyalphabetic. I want to make it short. Look, I have A is being mapped to M, and also when another A is coming up, this is being mapped to something called T. So every single letter is being mapped to some different letter. So A one time is mapped to M. Now the second time when A came in, it mapped to T. The third time A came in, it mapped to D, which means it's polyalphabetic. Mapping is different. There's many mapping to the same letter as compared to monoalphabetic. Same letter is going to be mapped to the same letter, same ciphertext, regardless of how many times it appears in our text. So that's the idea behind polyalphabetic. This is harder as compared to monoalphabetic ciphers. But still, you don't want to use any of these traditional ciphers because the computational capabilities nowadays is very high, and this will be broken in no time. So let's quickly do decryption. In decryption, you get ciphertext minus ki. So this is your ciphertext. You subtract this. So 12 minus 12 will give you what? 0. 12 minus 12 will give you 0. 0 mod 26 is 0. So you get A. In decryption, so ciphertext 19 minus 0, this is your key. So 19 minus 0 would give you 19, and 19 mod 26 would give you 19. That's why you have 19. Now check this out. This is going to be a little bit tricky. 12 minus 19. So this one is, so we're subtracting this. 12 minus 19. As we know, so 12 minus 19 mod 26. Now if I were to look at it, I'll get a negative value, isn't it? So this is how we normally do. So we're going to forget about this negative now. We're going to subtract 19 from 12. I would get what? I would get 7. So I'm going to bring that negative 7 out, take a mod with 26. All right, isn't that what it is? All right, so what do I do? So if I have a negative number, what do? I'll ignore the negatives. So 7 mod 26 is 7. Because modulus is bigger, number is smaller. And I'm going to bring that negative 7. I'm going to add 26 to it. So 26 minus 17 would give me 19. Hence, we have 19 in our decryption part, which is T. All right. So this is how you do it. I hope you like this small tutorial. on polyalphabetic cipher, specifically autokey cipher. And please don't forget to subscribe to my channel. If you have any questions, leave it in our comment section.